Right, let's do subtopic 2.3, which is on projectile motions. Okay, so in this subtopic, you need to be able to describe a projectile motion launched at an angle, as well as when the theta is equal to 90 degree, which we all know is known as free fall. Okay, and then of course you have to also be able to solve problems related to projectile motion. Okay, so what is actually a projectile? So it is actually a body that is being projected with an initial velocity, and it travels in the vertical plane under the action of gravity. Okay, so it consists of two components. It has y component as well as x component. Okay, so y component, the motion is only due to constant acceleration, whereas horizontal component, the motion is with constant velocity, hence the acceleration is equal to 0. Okay, so the table here is a summarization for both horizontal and vertical punya formula. Make sure you are able to understand this because we are gonna be using these formulas throughout our chapter 2 punya problems. Okay, now we look at this. Let's look at this diagram. This is a projectile motion. So this ball is being projected at an angle theta, and then we are gonna be looking at point P and point Q. Okay, so at point P, the x component would be equal to v1x will be equal to ux. Why would it be equal to ux? Is because we know that there's no acceleration on the x component, so it will always be equal with this one. Okay, so ux is equal to u cos theta. Okay, so this one ni di sini ni u cos theta. We are resolving this u in x direction, in the x component. Okay, so for point Q pula mestilah sama juga, right? So it is v2x equal to u cos theta. V is equal to u cos theta lah. Okay, next y component. Let's look at y component for point P. For y component, it is v1y. Okay, so v1I, we can find it by using the formula uy minus gt. Okay, t1. Okay, sini ada t1. So kita boleh cari v component for this point using inilah, using this formula. Okay, same goes to the for point Q. v2y is also equal to uy minus gt number second 2. Okay, and then for magnitude, we know we can find it by using the formula vx plus vy square, and then this one is square root all of them together, and then the direction can be calculated. Tangent theta equal to vy over vx. Okay, same goes to point Q. Okay, so these are some of the formulas which is used to calculate macam maximum height, time taken to reach maximum height, flight time, horizontal range, value of r maximum, flight time. Repetitive pula. Okay, so maximum height ni happens when the velocity is equal to 0. Velocity at y here equals to 0. Okay, selalu kalau kita buang bola, they stop at a certain point, right? And then baru dia jatuh balik. This point is known as its maximum height, in which v is equal to 0. Okay, right. Now we are going to look at free fall. So free fall ni defined as an object falling only with gravitational acceleration. Okay? It falls due to gravitational acceleration, and the acceleration is independent of the mass, okay? It is always constant and independent of the mass. So these are some of the formulas we will be using for linear motion in comparison to free fall. Okay, so free fall kita guna negative g tau. Okay? Because the direction is towards the center of the earth, which is downward. That's why the acceleration will be negative g. Okay? Alright, so that is the theory part for our last subtopic, which is projectile motion.